Hey guys, returning back to chapter 7, the cardiovascular system. Now this is going to be part 2. And like I said, now we're going to be talking more about these arteries, or actually I should say blood vessels, because that's a more general term. And I say that because when I say blood vessels, it's going to encompass both your arteries, both your capillary, which there's only one of. With arteries, you'll see there's a breakdown. And then the last bit, which is your veins. And then there's a breakdown, different types of veins. So let's start off with arteries. What are arteries? They're going to be thick, highly muscular blood vessels that are going to be elastic. And that makes sense because I told you arteries are responsible for carrying blood away from the heart. So you know they've got to have some kind of contractive or pressure increasing element to them. And what is that element? That is this muscular membrane they're going to have, right? And the membrane is going to be thick, so that the thicker it is, so there's elastic recoil, right? If it's thick. And the muscular is, again, that also contributes to its elastic recoil. And as a result, when it pumps, it's almost like it's shooting blood out, which is what it needs to do in order for it to carry it towards the rest of the body. So that takes care of the arteries. Now, arterioles are literally what happens, if you recall when for the lungs, and I was talking about you have a major bronchus, and then that's going to branch out into smaller bronchioles and etc. Same concept here. You have a major artery, it's going to branch off into a smaller artery, and arterioles are pretty much that smaller artery that branches off from a major artery. And what it's specifically going to do is going to connect to capillaries, which I'll talk about later on. So based on, if you want more blood flow into capillaries, or you want less blood flow into capillaries, what's responsible for controlling the flow of the blood into it? Arterioles. So how would it control it? Vasodilation or vasoconstriction. Those two things that would allow arterioles to control blood flow into the capillary bed. And that's exactly what its function is. Finally, you're at the capillary bed, and you know what happens at this stage. Gas exchange. Why? Because for a blood vessel, it's literally one cell thick. To make this capillary, it's one cell thick. In fact, as a result of its minuscule structure, when blood flows through it, the blood cells are literally flowing through them one by one in a line fashion. That's how small it is, to give you perspective. And as a result, it enables the movement of nutrients and gases and waste via simple diffusion. That's all you need, just because of such a small distance between the blood and the vessel itself. Now we're going to move on to veins, right? So we talked about arteries, they're going to branch off into arterioles, and then you're going to get into capillaries. After capillaries, you actually end up with venules and then veins, if I were to kind of show you the flow of blood. But the reason why I'm going to explain veins is because venules they're the same as veins, but just smaller, right? So what are veins? Contrary to arteries, you need to understand they're inelastic. It's going to help you in MCAT questions. They're thin-walled, so they don't really have a recoil elasticity, but they do have the ability to stretch, and as a result, they can hold large volumes. This is not something you need to memorize, because this is something that should just make intuitive sense. I told you veins are responsible for carrying blood back to the heart. So instead of arteries, which is responsible for pumping blood away from the heart, so you need that pressure contraction, venules just need to make sure that they can dilate so that they can accumulate all this large volume of blood that's got to return back to the heart so that it can go to the lungs again to get oxygenated. And that's exactly what happens. It's thin-walled, but it's able to stretch so it can accommodate the large volumes of blood. And therefore, it doesn't have recoil capacity, but it doesn't really need to in all intuitive sense. So you might be wondering, there are some places in your body, like your legs, gravity is pulling the blood down, so how are the veins able to carry it back to the heart if there's no really elasticity component to it, like arteries? The explanation is these veins have one-way valves, so that means blood does not flow back. It always flows ahead when they're in the veins. So not only that, they also have skeletal muscles surrounding the veins that compress and put pressure on these veins, and as a result, the muscles are kind of providing that muscular contraction to move the blood away. The veins themselves don't have this. The arteries do, but not the veins. Okay, so that's something important you need to understand. So that takes care of this, right? Flow of blood. You go from arteries to arterioles to capillaries to venules and then veins and then back to the heart and then repeat pretty much. What is a portal system? A portal system is just when you have two capillary beds that are in series. Recall from, let's just say, your physics lessons. You know what for two things to be in series, it means you have one and then you have the other one right next to it. The reason why I'm making you recall to a physics is because I am 100% sure in the physics section, especially when you're learning about resistance and circuits, one thing MCAT loves to do is apply it to a biological context. And the biological context is these blood vessels, because blood has to flow through them. So there you go. You have the physics flow rate equation, Q equals, I think, current times, let's just say, area, right? There you go. An application of a physics context, but in a biological setting. And MCAT is going to love to do that. So you really want to focus on, obviously, that lesson, but make connections between that and here. So a portal system is going to be when you have two capillaries in series. They're going to be next to each other. As soon as blood flows through this capillary, it's going to go through the other one without kind of going to the venules and everything else I said before. There's only three that kind of got out of the video. There's only three portal systems that you need to be aware of for MCAT testing purposes. First one is the hepatic portal system. So this is something that will be more relevant when I start talking about the digestive system. Why? Because it's a portal system where blood travels from the capillary beds in the gut, so where absorption happens of nutrients, to the liver capillary bed directly. And through what? Through the hepatic portal vein. So these two capillary beds are going to be in series with each other, and as soon as blood passes from that capillary, it's going to go to the next one. You'll see the relevance later on. For the hypophyseal portal system, blood's going to travel from the hypothalamus directly to the anterior pituitary. So the capillary in the hypothalamus directly to the capillary in the anterior pituitary. Now, here you should already have made a connection because I already covered the endocrine system and I already have covered the nervous system. And I remember that I have already mentioned this, and I can connect this to what I've taught before and kind of appreciate why there's a portal system here. Because these two capillary beds are so close to each other, all the hormones that are produced by the hypothalamus are going to get sent to are going to be able to communicate with the anterior pituitary without any interference. Now, don't you think that's important? A system, endocrine system, responsible for carrying messages long distance from one cell all the way, let's just say, in my brain, all the way to my leg. That's a long distance for a hormone to travel, and that's a long distance for one cell to communicate to another one. Don't you think it's going to be important that there's no interference with that message? So how is the body able to accommodate that? It's through this hypophyseal portal system. The fact that these two capillary beds are so close to each other, they're in series, enables that whatever gets sent to the hypothalamus reaches the anterior pituitary without any kind of chemical interfering with it. Last one is going to be the renal portal system, and that's where your blood travels from your glomerulus to the vasa recta through the afferent arteriole. Right now, at this point, you might not understand even these structures because I haven't covered the excretory system, but I promise this is something we'll visit back and you'll understand more. But from right now, the only thing I'm gonna be really brief. The glomerulus is a structure kind of filters your blood in the excretory system because the wastes are going to form a fluid that eventually is going to exit your body as urine, right? So glomerulus is that kind of that filter, so that your red blood cells don't kind of pass and you're not bleeding out, right? And then the vasa recta is just going to be the kind of the network of, let's just say, capillaries or arteries that are going to be revolving around this structure that filters, which is the glomerulus. And allows exchange of materials because water isn't the only thing you're excreting in your urine, right? There's going to be a little bit of glucose, there's going to be some other solutes that you're going to excrete. How does that happen? The interaction between the blood and then this filtering device, the glomerulus. We'll go more into detail about that when we hit the exclusion system. As of now, we've just completed part 2 of chapter 7. We'll be moving on to the next part